Hello everyone. In last lecture we have discussed what is elasticity, plasticity, rigidity and stress and strain. In this lecture I am going to discuss types of stress and types of strain. Okay, now let us see first type of stress. Okay, here you can see that the first type of stress is normal stress, and normal stress is defined as deforming force is applied normal to the area, then the stress is called normal stress. Okay, let us try to explain normal stress by taking one example. Now I am going to take one object, then I am going to apply deforming force F normal to the area. Here also I am going to apply deforming force normal to the surface or area. Then after applying deforming force, this object undergoes deformation due to this force, that is deforming force which is applied normally on the surface. Then what happens? This body undergoes deformation and this body develops some restoring force. This restoring force which will try to bring it to its original size and shape. In this case, the restoring force per unit area is defined as the normal stress. Okay, what is normal stress? It is simply when we apply force normally on the surface, then the restoring force which is developed in this object at that time, the restoring force per unit area is defined as the normal stress. Okay, now let us see the types. In normal stress there are two types. The first one is tensile or longitudinal stress, and the second one is compressive stress. Here let us see the first type of stress, that is tensile stress. Here you can see that if there is an increase in length, then stress is called tensile or longitudinal stress. Let us explain this tensile stress by taking one example, that is in last lecture we have taken rubber band. To explain this longitudinal stress, I am going to take the same example. Here what I have done, I have taken a rubber band and its one end is fixed. Then I am going to apply some amount of force on other end. Then in this object a restoring force is developed. This restoring force magnitude is equal to the amount of force applied. Then what I am going to do, I am going to remove this applied force. Then this object will regain its original size and shape. In this case what we have observed, there is increase in length. In this case the restoring force per unit area is defined as a tensile or longitudinal stress. Here you can see that. Let us suppose this is the object and it is the cross sectional area A and it is the length L. Its one end is fixed and I am going to apply some amount of force F in downward direction. Then what we are going to observe, there is increase in its length. Here you can see that this is the cross sectional area, this is original length and it is the change in length, that is increase in length after applying deforming force F in downward direction. In this case, the restoring force per unit area is defined as a tensile or longitudinal strain. Here what we have observed, when we apply normal force, then there is increase in its length. At this time we can define longitudinal or tensile stress as a, if there is an increase in length, then stress is called tensile or longitudinal stress. Okay, now let us see the second type of stress, that is compressive stress. To explain compressive stress, I am going to take spring as an example. Here what I am going to do, I am going to fix its one end and I am going to apply force in upward direction. Then what we will observe, there is compression. Here you can see that the body undergoes compression. In this case, the body develops some restoring force. This restoring force will try to bring it to its original size and shape. In this case, the restoring force per unit area is defined as a compressive stress. Okay, let us try to explain the same example diagrammatically. Here I have taken one object and it is having some cross sectional area A and some initial length L. Then I am going to apply force in downward direction. Then what we are going to observe, here you can see that when we apply force, here I am going to apply force in upward direction. Then after applying normal force in upward direction, this body undergoes compression. This is, you can see that it is the area of cross section. This is the amount of force applied, F, and you can see that there is change in length. Here what we have observed, there is decrease in length. In this case, the body which develops restoring force, in this case the restoring force per unit area is defined as a compressive stress. Compressive stress means if there is decrease in length, then the restoring force per unit area is known as a compressive stress. Okay, now we have defined the first term, that is normal stress. In normal stress, we have studied two types of stress, that is longitudinal or tensile stress, and second one compressive stress. Okay, now let us see the next type of stress, that is volume stress. Here you can see that volume stress is simply the applied force produces change in volume of a body. The stress associated is called as a volume stress. Here I will try to explain volume stress by taking one example. Here you can see that I have one object and it is having some volume V1. Then what I will do, I am going to apply force in all direction. Then what happens, this body undergoes deformation. Here you can see that, and we are going to observe some change in volume. Okay, let us try to explain the same situation diagrammatically. Here you can see that we have taken one object and it is having some initial volume V1. Then what I am going to do, I am going to apply force F in all directions. You can see that I am going to apply force in all directions. Then this body undergoes deformation. After applying some amount of force F, and which is having volume V2. Then here what we have observed, there is decrease in volume. Then after removing this force, that is applied force, then this body will regain its original size and shape. In this case, the body, after applying force F, this body develops some restoring force. Then in this case, the restoring force per unit area is defined as a volume stress. Here you can see that if the applied force produces change in volume of a body, then the stress associated with this body is called volume stress. Okay, what is volume stress? Here you can see that. What is volume stress? If the applied force produces change in volume, then the stress, that is restoring force per unit area associated, is called volume stress. Okay, now let us see the next type of stress, that is shear or tangential stress. Here you can see that shear or tangential stress, it is defined as the applied tangential force produces change in shape of a body, then the restoring force per unit area associated is called as a shear stress. Okay, now let us try to explain shear or tangential stress by taking one example. Here you can see that I have taken some books. Let us suppose consider this entire object. Then I am going to apply some tangential force on it. Its lower end is fixed. I am going to apply tangential force on upper face. Then what we are going to observe? There is some displacement. It is initially in this position. After applying tangential force, there is some change in this object. Here also you can see that there is some change in object. Okay, let us try to explain this same concept diagrammatically. Here you can see that I have taken one object which is having some initial length L. Then what I am going to do, I am going to apply some force F on upper surface and its lower surface is fixed. After applying some amount of force on upper face, what happens? There is some change in its initial position as compared to the initial position. Here you can see that after applying force there is some relative displacement, and we will denote this displacement as a delta x, and also there is some change in angle theta. In this case, here you can see that after applying some tangential force, this body undergoes deformation. Then this body develops some restoring force. This restoring force will try to bring it back to its original size and shape. When we remove this external force, at this time, the restoring force per unit area is defined as a tangential or shear stress. Here you can see that what we have done, we have taken one object, it's having some initial length L, and then we have applied some amount of force F. After applying force F, this body undergoes deformation. There is some displacement. We have seen some displacement delta x by making an angle theta. Then after removing this force, the restoring force which is developed in this body will try to bring it to its original size and shape. In this case, the restoring force per unit area is defined as a tangential or shear stress. Okay, now we have discussed three types of stress. First one is normal stress, second one is volume stress, and third one is shear or tangential stress. In normal stress, there are two types. One is longitudinal or tensile stress, and second one is compressive stress. If the